In this video, we will solve a system of linear equations by graphing them. So here we have a system, and I've labeled them 1 and 2 in 2 different colors so that we can keep track of that as we solve the problem. Let's start by graphing equation 1 by plotting points. So what does that mean? That means that we can choose two x values, any two x values, and plug it into our equation, get out a y value, and then plot those points. So first we need to choose two x values. We can literally choose any two x values and plug them into our equation and plot those points. Now I do recommend choosing x values that are centered close around the origin so that you don't get points that are far off your graph, because that wouldn't really be useful in terms of graphing. So for example, I'll choose -2 and 2. I usually like to choose one positive and one negative. And then we take that and we're going to plug those x values into the equation of our line. Remember, this is the equation of equation 1. So we're going to do -2 plus 7. So -2 becomes +2 plus 7, which becomes 9. So now let's plug in +2 plus 7, which becomes -2 plus 7, which becomes +5. So now the two coordinate points that we have to plot are -2, 9, and 2, 5. Remember, those are x values and y values. And then we can take those two coordinate points and we can plot them on our graph. -2 on the x-axis and +9 on the y-axis, plot the point. And then +2 on the x-axis, +5 on the y-axis, plot the point. And then we need to draw in the rest of our line. So we can just draw this by connecting the dots. And I'm trying to be actually a little more precise than I normally would, since I'm using this line to actually find the solution, to find out where exactly it crosses the other line. So how am I being precise? Well, I'm going back up and I'm looking, what is the slope of this line? The slope is -1. So really this line should be crossing every single box here, because the slope is the rise over the run. So -1 would be down 1, right 1. So to help me finish drawing the line, I may just kind of plot points like this and then connect them so that my line is maybe a little more straight than it would be otherwise. Then I'll draw arrows on the end of it to denote that it continues going. Okay, let's do equation 2. I'm going to get a different color so I can keep track. Now equation 2, it says to graph using the y-intercept and the slope. So what does that mean? Well, it means that we're not actually going to plug in x values and get out y values. Instead, we're just going to use the fact that the slope of equation 2 is this value right here. Sometimes you see this as y equals mx plus b, where m is the slope and b is the y-intercept. So our slope is +2/3, and our y-intercept is that point 2, which if we write it as a coordinate point is 0, 2, or x, y. So let's plot that y-intercept at 0, +2, and then now we actually use that slope of 2/3, +2/3, and we remember that slope is the rise, or the up and the down, over the run, or the sideways, the left, right, and that's how we get the rest of our points. So for a positive slope, I know that my line is going to be going upwards from left to right. So I'm going to rise 2, or go up 2, and then run, or go to the right, 1, 2, 3. Bingo, I just crossed my other line. That's the solution. That's where they cross. But let's keep drawing our line. Let's keep doing the equation 2 here. So rise 2, 1, 2, over 3, 1, 2, 3. Then my next point there looks like it's at 6, 6. Let's do that one more time. Up 2, right 3. My next point looks like it's at 9, 8. Now we can go back the other way, right? Because our line, if I wish to draw this, keeps going this way. Sorry, that's not very straight there. To get those other points now, imagine it's going down this way. We actually need to go opposite of our rise over run, meaning instead of going up, we're going to go down. Down 2, and then instead of going right, we're going to go left. Left 3. So our next point there is actually at -3, 0. Down 2, right 3. Next point is at -6, -2. You could do another one. I think I'm just going to connect this super not straight line and call it good. Because the whole purpose of this was to find the solution. The solution is where two lines meet or cross. And I found it right there. So the lines cross at this point, 3, 4. That's the solution to that system of equations, the x value 3 and the y value 4. What does a solution mean? A solution means when you plug in 3 for the x and 4 for the y into this solution, or to this system, then you will get true statements. Don't believe me? Let's try it. So our answer, our solution is 3, 4. You can write it as a point, or you can write it as x equals 3, y equals 4. Just to make sure we did it all right, we always want to check our answers. So that means we need to plug 3, 4 back into equation 1 and back into equation 2. So when I say that, I mean to take equation 1 and plug in the value of 3 for x and 4 for y. So we get 4 is equal to -3 plus 7. And I put a question mark because I'm checking, so I want to see is it true. And it is true. 4 does equal 4, so that's true. Does it follow suit in equation 2? Let's check. Does 4 equal 2/3 times 3 plus 2? Fractions. It's all right though. 3 and 3, those simplify, cancel out, so we get 4 equals 4. We're good to go. Our solution checks out, and that's how we solve a system by graphing.